The next talk is presented by Stephan and Fran. May I ask you already to move here while I introduce your talk? Are you here, Stephan? Yeah. So we will now next learn something no less than exciting, because we're forecasting the future. And after the next presentation, we will all hopefully find out who will win the European Soccer Championship in July. Maybe you can tell us or not. Let's see. Stephan and Fran, you're both from StatWorks. You both have a technical background. Stephan studied data science at ETH, working on NLP, computer vision, and forecasting. And Fran is from university, has a background data science from University of Zurich, and also busy with computer vision, forecasting, and reinforcement learning. So, without further ado, I'm very much looking forward to your presentation and hopefully learning more about the future.
Thank you very much. All right, let me quickly check here. Okay. All right, hello everyone, and welcome to our talk. So I would like to start my talk with a small question. What is the #1 use case or data science use case that most businesses face today? Forecasting. 100 points. So yeah, from our experience, it's time series forecasting. And that's what we will talk about in this talk. I will present you what are common problems in time series forecasting and how we tackle these problems with our solution. The goal of our solution is to make time series forecasting more accessible to everyone. All right, who are we? We are from StatWorks, and StatWorks is a consultancy and development company. We are focusing on artificial intelligence and implementing artificial intelligence projects with our partners. We are applying, or we are conducting projects in different fields of artificial intelligence and across different industries. So my name is Fran, and I'm a data scientist at StatWorks. I'm mainly focusing on computer vision and time series forecasting, and in my free time, you can find me on the basketball court.
I'm also a consultant data science at StatWorks, and I've focused on the area of deep learning, and in particular, natural language processing and time series forecasting. And in my free time, I also like to do sports, and particular field hockey and swimming.
All right. So in this talk, we will first have a look at what is a time series. So I will introduce you to this area, and we will show you then our solution. Especially, we will present the performance of our solution. Later on, Stephan will present you what our solution is based on, and he will showcase how to interact with our solution. So what is a time series? Time series can be encountered in many different fields, and that's because anything that is measured over time is a time series. As an example, sales of a certain product is a time series. Measuring the temperature over time is a time series, and many more examples. So I would like to start with having a look at different time series first. Time series in general can look quite differently, and that's because of their components. Here we have a strong seasonality time series. Seasonality means that there is a pattern that is repeating over time. You can think of sales of ice cream. In summer months, the ice cream is really popular, and therefore there will be high sales. However, in winter months, the popularity decreases sharply. In this case, we have a time series with a non-linear trend. So the time series is increasing over time, however, non-linearly. Here we have a more wigglier time series. However, globally, the time series is increasing linearly, and that would be an example of a linear trend. Here we have a time series with a constant level over time with a bit of variation. So what you see here is monthly data over 8 years. And we can use this data in order to extract information from the behavior of the time series. This is quite important because we can use this information for planning and allocation of resources. So here, a model was fitted on the data and was able to recognize the seasonality pattern in this time series and was able to extrapolate this information to the future. So the next 12 steps were predicted and estimated. And we can use this for other time series as well. Now, a common problem in time series is that we don't have enough data. So that is called the cold start problem, and this graph depicts this problem. This time series is not long enough. So think of introducing a new product where we don't have a long history of data, and we are not able to reliably find this pattern in the time series. This is actually one of the common problems that I would like to discuss with you. We have the cold start problem, and we tackle this problem such that we trained a model which is able to generalize. So the idea here is that the model has seen a lot of data from different domains with a lot of different looking time series. And it is able to predict and forecast on time series that it hasn't seen before. The next problem in time series forecasting is the forecast at scale. So forecasting one time series might be an okay task. However, forecasting 11,000 products is quite hard and more of a challenge. So traditionally, you would have to fit a model on each time series because each time series, or each product, sorry, each product has a different behavior, and therefore the model has to be fitted on each time series. Now, because our model is able to generalize, we don't have to fit anymore. So there is no training going on, but we can take the input of the time series, and as an output, our solution will provide you the forecast. So time to forecast boils down to inference time. And the third problem that I would like to mention is not everyone is able to create or implement such a forecasting system. And our solution was built such that it's as simple as possible to interact with it. Stephan will later on showcase how to interact with it, and you will see how you can provide your own time series to get output from our model. All right, next I would like to discuss with you the performance of our model. And we evaluated our solution with other options. For this evaluation, we used 5 open source datasets, which are listed here. Those datasets contain data from 4 different industries and 3 frequencies. So daily, weekly, and monthly data is what we focused on. In total, that's about 36,500 time series. And here you can see the results. So on the left side is our time series, our solution, the forecasting API. And we compare it with artificial intelligence solutions from Azure, the Microsoft Cloud, Amazon Web Services, and Gluon. So now you can see performance is, and I would like to highlight here that our model has not seen the data before, whereas the other options or competitors were trained on the data that we used for evaluation. And nevertheless, you can see that our solution most of the time beats the competitors. The other thing is the time to forecast. So because we don't need to train our model, it takes 5 minutes to get a response from our model. So the time to forecast is down to 5 seconds, whereas the other options have to be trained on the data in order to get your forecasts. And finally, the required expertise. So our solution is concepted such that it's as easy as possible to interact with it. The other options have to be set up programmatically, and it requires some expertise in this area. Now I'll hand over to Stephan.
Thank you. Now, after we've heard what our forecasting engine or what problem our forecasting engine can solve, I'd like to give you a further background on the theoretical foundation which it builds on, namely zero-shot time series forecasting, or more general, zero-shotting. To understand zero-shotting, we first have to take a step back and understand how a machine learning model is generally trained. So usually when we train a machine learning model, we collect data, a large amount of data for a certain problem, and then train a model on this by splitting the data up into two distinct sets, two disjoint sets, a training data set and a test data set. The train data set is used to fit our model parameters, and subsequently, the model is then evaluated on the test data set. This performance on the test data set can be used as an idea of how this model will perform on new unseen data. The drawbacks of this modeling approach are, especially if we look at our forecasting engine, that a large amount of problem-specific data is necessary, and also that this model can afterwards only be used for a single task, namely to do inference on the data set it was trained on. Further, for time series forecasting, we also need a significant amount of history, since we have to split the time series in time, or split our data in time, and thus need often a multiple-year horizon, so the data has to be acquired over a large amount of time. And this is one problem, as Fran mentioned before, and with the cold start, which we can alleviate with our model. So going from here on to zero-shotting, zero-shotting actually means that we apply a model on data which the model has never seen before. So you can imagine the training process of a zero-shotting model by collecting large amounts of problem-related data, and then the model is trained on this data. Then this, sorry, I stepped ahead a little. Exactly. So what we actually do is we train a model on a variety of data sets which are related to the target domain, and then afterwards it is evaluated on data sets which the model has never seen before, as opposed to taking one data set and splitting it up into a train and test set. If we take an example from computer vision that you maybe understand better, the concept of zero-shotting is, imagine we have a classifier, an image classifier, which is able to predict the classes horse and whether an image contains stripes. Then assume that this model is then provided with data from a new class, and then sees a zebra, which it has never seen before. So this is exactly this zero-shot realm that we are in. Then we can actually use the knowledge from our model that we trained and say, okay, if we have a high probability of this image containing a horse and of it having stripes, then we can use this to infer that the image contains a zebra. As we are in the forecasting case and not in this classification case, as we looked at here, the problem is slightly different for time series, namely that we are faced with the challenge of developing a model which can treat data from different domains and with different characteristics. So that means it can have different seasonality patterns, trends, and all the characteristics of time series Fran mentioned in the beginning. So our challenge here is to find a model, and this can be trained with this zero-shotting approach, which can use information gathered by seeing a lot of data, different time series data from different domains with different characteristics, and then use this to forecast on data which the model has never seen before. So we chose a deep learning model architecture for this problem, and I'd now like to give just a short background, because I think we're running out of time already, about what deep learning is, and then why we chose a deep learning approach as opposed to a more conventional time series forecasting approach. So deep learning is a complex modeling approach which is based on neural networks. So we can imagine this, that input data is transformed in subsequent layers, and representations of this data are computed. Then, in the final layer, this representation can then be used to do inference or to solve the problem which we want to do, in our case, time series forecasting. Advantages of these deep learning architectures are that they are very flexible and thus able to solve complex problems, and that feature engineering, which was typically before deep learning a manual effort, is inherently covered in the model. Disadvantages or challenges of these deep learning models are that they require a lot of computation time, so that we need a lot of time and also computational resources to train these models, and that the architectures that we can build with deep learning are very diverse, and it's very hard to figure out which model performs best on a specific task. Deep learning has also proven to be the go-to modeling approach when treating image data, audio data, or video data, and also performs really well on sequential data, which can be language or time series, as in our case. So why is deep learning the model approach of choice, which we chose for our forecasting API problem? This is, on the one hand, because the deep learning models are very generalizable. Because we have a lot of parameters, these models can extract features or extract information from large data sets, and can then use this information to do forecasting. So we have, on the one hand, this generalization is allowed by the amount of parameters we have and also by the intermediate feature representations which are calculated. Further, this flexible architecture or the number of parameters enable us to leverage the large amounts of data that we have available to train our models. So as Fran explained beforehand, we gather data from different fields, so time series data from finance field, retail. We have a lot of data from different industries with different characteristics, and the model, due to its flexibility, is able to learn patterns from this large data pool. Then the last aspect is that we have cross-series learning. So conventionally, time series models were learned on a single time series level, so that the information, all the information that is available when we do forecasting is what the model learned from a single time series, and these deep learning models allow it to take a step further and to make use of what other patterns were recognized in other time series to apply to a certain forecasting problem. Exactly. So now I would like to explain, give you a short overview of how you can interact with our forecasting API platform. And this is in the form of an API, which means application programming interface, and which is actually an interface to communicate between different software components. And the way this is done is a user, which can be Master Yoda, you or me, has time series data available and then wants to get a time series forecast. What has to be done is that our data is transformed into a standardized form, which can be processed by the API. So a JSON payload, which can be sent to the API. And an example can be seen here. Then, after sending this out, the model processes this time series automatically, so we don't have to specify anything further. And the model then creates a forecast from there and returns the result in this same format. This enables us to use these forecasts in our own setups or in your own diverse setup, depending on what you use, what infrastructures you use. So you can imagine if we have data stored in a database, we can then extract the time series information, put it into the format, then start an API call, get a forecast back, and write these forecasts to the database, from where on this information can then be further used, analyzed, using the data analytics and BI tools that you use already. So nothing further that you have to take into operation there. And yeah, good. Another use case would be if you mainly work in Excel, that you have your data in Excel, then you extract the information there and can write the forecast back into Excel and do your analysis further there without any more to do. I would now, because we don't have time to set up database infrastructure or anything to test this out, I would like to show you our landing page, which we developed so that you can easily get a feel for how our forecasting engine works, how it performs on your own data, and so that you can be inspired on how you could leverage this for your own use cases. And yeah, so here we see the platform already, and there are different ways you can use it with. One is supplying your own data in simple CSV format with date and time. So if we go there where you have energy, where you have the selection, you can select your custom data type, or also, exactly, you have custom upload, which you can choose. And then you can upload your own CSV data. And if you don't have data available, you can use data which is supplied by us. You can load the data and then create a forecast to see how this looks for different domains. We have an example out of retail, a crypto example, and a retail example. Then, yeah, could you go one slide back? Thank you. So we would like to encourage you to test out our platform and give us feedback, and we hope that we can thus inspire you to use time series forecasting to automate your processes and workflows in your business further. And we'll afterwards also be on the Lucerne terrace at our booth, and we'll be happy to talk to you about time series forecasting, AI in general, and you'll also have the chance to test out this landing page. Thank you.
Thank you very much, Stephan and Fran. I'll just go into the middle. Thank you very much. Now we know how to predict the future. Any questions for the future from the audience? You have to go to the mic, please.
Yes, maybe two questions. One question is about the license model you have here.
Yeah.
And the second one is the performance of 40% does not look very high, so maybe you can explain what it means
so the performance actually relates to the amount of cases in which our forecasting engine outperforms the benchmark models. So we have this AutoML, which we use for Azure and AWS, which actually trains a model specific on the data that we then forecast on, and then we check in how many % of the cases does this benchmark outperform our model, or in how many cases is our model the best? And compared to AWS, Azure, and Gluon TS, which is also a time series library which Amazon developed, we then see that in 40% of the cases, even though we never saw the data before, our model outperforms these competitors, which are all already strong competitors in this field. And your first question was license model.
So yeah, we are still in the rollout phase, and therefore this is the alpha version of our model, and we are still trying to get the feeling what our partners would like to have from our solution, and we are still working on the license, what it looks like and what it will look like.
So you're looking for pilot customers?
Absolutely, yeah.
Any more questions? I see lots of hands.
Hey, you said crypto, or?
Yes.
Okay. So how does this work? Because there's nothing more probably volatile than cryptocurrency.
Agree. So we use crypto just to check how well our model performs on those kinds of time series. It was just a case where we evaluated how well our model is performing on this kind of time series compared to the competitors. So unfortunately, I don't have any metrics here with you to share, but yeah.
But on this context, you must know Bitcoin 2022, one year from now.
Of course, we can talk about that afterwards. We don't want to share our knowledge.
I would like to record it on the camera, and then next year you can be right or wrong. Okay, Georg has a question from the online audience.
Yeah, there's one from David Lindelöf. Are the datasets used to train the model related to the datasets used in the evaluation?
So, no training dataset that we used in the training for training is used in the test set for validation.
So the datasets are actually from related domains, but we don't use data which comes, for example, from the same company or were generated by the same process. So you can say you have related datasets, yes, but we never use the same dataset, because then we would not be in this zero-shot forecasting.
Yeah, it makes sense. Okay. I've got one more, or one from the audience?
So you're already standing there.
Okay. Okay, there's one more. From Hendrik, so how does your solution actually differ from other solutions like AWS or Azure? They also use deep learning for time series?
Yeah, yes. So the main difference is that these models actually use AutoML, or the automated solutions that they provide is they use AutoML and then also do training. And this was the time to forecast, which Fran mentioned. So if you have to upload a large amount of data, and it also takes time to train these models. In our RAM, we have zero-shotting, which we use, so you don't have to train a model anymore. and your time to forecast is in low second area, and you don't need a history which you can fit the model on. So that's the main difference, that AWS, these automated services, AutoML services, still train models, and we have gone away from this training a model specific for these time series to having a generalizable model which can then be applied to various time series from different domains.
So many questions. I think you are next. You could already make your way up to the microphone and keep the 2-meter distance.
Have you looked into multivariate time series or not at all yet?
So the problem with multivariate time series is that we have to actually know what these different dimensions mean. So we can't take into account, for example, external data in this setup, and that's not our goal either. Our goal is to provide a simple solution which provides viable results for any kind of time series that you have. But of course, as you say, if you have multivariate time series and further information which you can leverage, you can get better performance if you then develop your own models again, but then you go again away from this setup and more to developing custom solution.
Do you plan to go there or not at all?
It's possible in some ways with the modeling architecture we use to also cover a multivariate case, and we're also checking out what we can do in this area, but not so far yet, and we're not far enough yet that I can give you more information.
Next.
There's 2 features that would be interesting, uncertainties, obviously, and labels for describing the actual behavior. Do you plan to do those?
So interpretability in a way.
No, in the sense that, it's a static curve, linear, chaotic, something, things that, take away a lot of the interpretation, that make it more accessible. You want to democratize,
exactly.
As you said.
Yeah. So in this initial phase, we don't have these features, but we have ideas how to enhance our solution, and we have ideas how we could include such an interpretability of the predictions of our time series, of the forecasts.
Maybe to get back to democratization, that we just understand the same thing. Our main goal is to lower the barrier that somebody can easily use time series forecasts without having the knowledge to create these models. So this is democratization in the sense of being able to roll out time series forecasting and make it available to much more people.
Is there still time for a question?
Yeah, well, okay. It's the break that you're cutting short, though, don't worry.
Okay, so come on. Thanks a lot. To be honest, a little bit, it sounds a little bit magic to me, but I like magic, so I'm totally fine. So one question, you had this sentence where you say that companies in the future with your solution are not then have to create or have to improve in data science anymore because there are a lot of problems and time series forecasting solved. Regarding to the tests that you did you also compare forecasting or time series forecasting within problems from teams of companies, not, let's say, just models that are out there? So as I saw on the slide, you compared with just models that are here. Did you also had some testing regarding time forecasting with specialists and also data science team of a certain field?
Okay, thank you for your question. No, we didn't check this. So far, we just checked on the model side what are our competitors and how do we compare with them. We haven't had the chance to see how well our forecasts are performing against human experts in a certain field. So that's something that we want to see now in this rollout phase, where we would like to partner up with people who are interested in our solution and to see is the forecast somewhere where the experts validate these forecasts, or is there a large deviation?
Yeah, so I'm talking about data scientists that do modeling in the companies. These experts, not human experts that say, oh, I did it 100 years ago like this. And so compare it to a data science expert team from a company that has the expertise of a certain field.
No,
that would be interesting because,
so far, and of course, in this setting, you have a huge advantage as a data science team because you can invest a lot of time. But I would like to emphasize that just the use case of our solution is if you have no data science team, you're interested in time series forecasting, and you don't have the money, resources, or don't want to invest in your own data science team, that we have a quick solution which you can use, which gives you high-quality forecasts anyway, which are not as good as what you could have if you have your own team, but which are available, quicker, and can be easily integrated. So we could evaluate it like that, but we know already that the performance would not be comparable to something that now a team of experts could develop over a period of months.
Okay. Yeah. Thanks.
Thanks for staying around. Thank you, Stephan.
Thank you.
Thank you, Fran.